For this part of the demo, I will be walking you through our VROC initium software. So if you look into the top left section of the software here, you'll see some important information, including the temperature at each point in the initium that is temperature controlled. So we have the chip temperature, the syringe temperature, and the temperature of the tray, which is where the 40 vial rack is located, or 96 well plate, whichever configuration that you are using. Here we have the serial number of the chip that is currently in use on the initium. So here we have chip 1831I B05 100 251. The next row is the system information, which will tell us some of the information that's being kept track of in the initium software. So here it's indicating that the cleaning step is done. And then over here it will tell you the volume of sample measured, the remaining volume left, and then whatever volume was loaded into the test syringe. And in here it will tell you information about the run, and here it says the job has been completed. And over here it'll tell you what sample is being ran at this given time. So on this run, or this previous run, we ran N10, which is an oil standard, a NIST oil standard, and we named it B05, the chip type, and then the serial number of the chip 251. And then on this row, it will tell you the measurement step that we're currently on, and then an estimated time. And then here it will say what the autosampler is doing. So it's saying the autosampler completed its loading, and it will tell you how long that takes here. And then here on the cleaning step, it will tell you the cleaning protocol that is in use and about how long that will take. And then over here on the right, top right, will tell you some other important information, including the volumes of the solvent bottles being used. And so if we hit this button here, it'll actually refresh and then repopulate the volume of the 3 different solvents used. And I would recommend clicking refresh before every run, just to make sure that the appropriate volume for each test is in each of the solvent bottles, because you don't want to be running your test and then run out of solvent halfway through and then need to restart or need to run a cleaning step before moving on to the next experiment. And then here's just a pictorial graph or pictorial plot showing where the flows are going in and out of. This will make a lot more sense during a testing run. So over here we have the usage counts of the consumables in the initium. So the test syringe, the autosampler syringe, the injection septum, and the wash septum here. And so the initium software will keep track of the usage counts, and it will highlight them yellow and red when you're approaching the lifespan of these individual components. All right, so now we can look at this big space here for some more information. So right now we have the experiment tab selected. So we have the experiment tab, the protocols tab, the data tab, settings, and information tabs. So here is the experiment tab. So just to show you how it filters through each of these. So we have the information tab that will tell you the information, settings tab that will tell you a lot of information about the usage counts and user accounts, and then some service utilities. And I'll go through each of these steps later in this demo. And here's the data tab, protocols tab, and back to the experiment tab. So in the experiment tab, it will tell you which job is being saved. So you can actually select this down arrow and you can go through previous tests, previous jobs. So let's say you're running an experiment again, but it's the same experiment that you ran a couple months ago. It's saved in the Initium software's memory, so you can select a previous, in this case, in 10 run, and it will remember the sample names, the auto sampler loading protocol, the measurement protocol, and the cleaning protocol from a previous run. So we'll go back to the first experiment or job that was saved on this instrument when we started this demo. And so here, if we scroll or look over to this big panel here, we have our job information. So which run, which vial. So if we have a 40 vial rack, we can go and add as many runs as we would like, but for this N10 run that we did, we had 3 vials, and we can name the sample anything we want. This average viscosity number is the average of all the viscosities from the run selected. This will populate once the run is complete. We have our recipe tab, which right here it says non-applicable because we're not running a recipe. A recipe is just a saved protocol. So if you're going to be running the same experiment multiple times, a recipe will just populate the loading protocol, the measurement protocol, and the cleaning protocol for you automatically, so you don't have to select each of these panels here. So next we have the auto loading protocol. So if you have an auto sampler, this is the loading protocol that you would select with an auto sampler. The next we have a manual loading protocol. So if you do not have an auto sampler, you can actually load your sample manually, and this is where you would select the type of manual loading protocol you would use. Next we have the measurement protocol. So you can create your own measurement protocols and run them, and you can select those pre-made or self-made measurement protocols here. And then we have our cleaning protocols here in this column, which again, the instrument has a preset list of cleaning protocols that we provide for you. Do not create your own cleaning protocols. There's a lot of research and development that we do in-house to ensure that the cleaning protocols are optimized for your instrument. So do not mess with cleaning protocols. We can help you create your own cleaning protocols if you ask, but do not make your own cleaning protocols. And then here is the recover column. So the recovery column is simply if you want to recover your sample after you've tested the sample. So you would click this box, and then you could specify which vial you wanted to recover the sample in. So I recommend putting it in a different sample, in a different vial than the one that you drew it from. So since we have 1, 2, and 3 vials used in this example, we would just select vial 4 and just have a fresh vial to recover the sample in. But I can go into more detail about that later. All right, so now I can go through and just show you how you would set things up. So I'm going to go through and just delete these. All right, so first things first, we would want to name our sample. So just say demo sample. And then we're not going to use a recipe. And then we'll want to use a loading protocol. So right now we have it set up for oil cleaning. So I will select oil cleaning. And then for a measurement, we'll just do just a standard preloaded measurement protocol. So let's see. I have a lot of protocols listed because we use this instrument a lot. So we'll just use one of mine. We'll do temperature sweep. And then for cleaning, scroll down, and we'll need to make sure that the cleaning selected here matches the cleaning in the auto sampler loading protocol. So to do that, just make sure it's the last thing in this case. Soap cleaning matches soap cleaning. All right, and then one final thing, we don't have a vial selected, so we want to come over here and make sure that the vial is selected. If we have multiple samples, we can of multiple samples on the same job that we want to run. Just click this, and it will add the same loading and measurement protocol and cleaning protocol for this particular sample. And one thing to note, you notice the vials are still vial 1, but we want them to go from 1 to 5. So to do that, we have up here on this tab the auto assign vials. So if we click that, and it asks you, do you want to assign vials automatically? Yes. And now it is populated 1 through 5. And then we can also move these around if we so choose with this move selected row feature. And then so we can add a new run. We can also delete the selected rows. And then we can also import and export sample names if you want to import and export sample names. And then you have a validation tab and save a template. So we can save this as a template if we so choose. And then here, the final things to look at are the temperature control. So if we want to turn the temperature control on or off, we can toggle this checkbox. We can set the tray temperature to whichever temperature we want, from 4 to 40 degrees Celsius. So you can select 4 and it will refrigerate your samples for you. You can set it to 37 for body temperature. You can set it to 25, 24, doesn't matter, just any temperature between 4 and 40 will work. So set to 24 before, so I'll keep it at 24. And then you can also dictate whether you want the temperature to be controlled after the job has been completed. And then here we have our pre-pressurization toggle area. So that's for certain vial types. Sometimes you need to pre-pressurize the vial for the auto sampler before loading, and so you would select that here. The auto sampler would draw air, and then it would inject the air into the vial before drawing up your sample. So that depends on vial type. And then you can dictate your injection speed, so the speed at which the auto sampler is injecting. I would recommend just leaving it at the default setting that we provide for you. So finally, we can start looking at these tabs down here. So this is just showing you which file we're looking at. So if I click file 1, it'll switch over to file 1, file 2, then auto assign vials, and you can see the software is keeping track of which file you're looking at, which will help you when you're creating your measurement protocols for the first time or running a job for the first time. And then you can also select whether the 40 vial rack here or a 96 well plate. So that's all in the design tab of the software package. So if we look at the graph tab, this is the data for the cleaning steps. So we'll just go to the measurement data, since that's a little bit more easy to interpret. So while it's running, it's keeping track of the viscosity as a function of time when it's doing its measurements. So the instrument will keep track of the viscosity as time increases, and it will wait until it reaches steady state before measuring the viscosity or averaging the viscosity across the chip. And then here, this tab is also keeping track of the temperature of the chip as a function of time. And then here, we're looking at the pressure sensor versus sensor position. So it should be a line like this with an R squared of at least 0.996. And then over here we have our viscosity values as a function of segment number. So segment number is just measurement number. So we can click and drag and zoom in and observe the viscosity of the chips, or the viscosity measured by the chip for each segment number tested. So that this was a shear rate sweep, so we'll look at it as a function of shear rate. So we can set the scale to default, and we can also look and see what the viscosity was at different shear rates tested. And so the this N10 oil standard, NIST standard, has a viscosity of about 15.84 at room temperature at 25 degrees Celsius. And so that would be about here. And we are well within the specification for this measurement. So 15.84 is about here, and our values are all within that range. And so down here in this section of the software, we can see what percent full scale pressure is being run, the viscosity, shear rate, and the cell temperature. And now this is all would be at real time. So this is keeping track in real time. This is your real time data. So right now it's not moving because we're not running the instrument. So we'll set the scale back to default. So if you right click, you can copy this image, save this image, print this image out, show point values. You can zoom in, unzoom. You can set the scale to default. So this is zoomed way out, but we can click and drag and then keep track of the viscosity as a function of both shear rate, temperature, and segment number. And again, this is the real time tracking of the software. If you want to look at the data once it's already been collected, that would be here in the data tab. So next we have a tracking of the temperature of the chip, which is here, VROC, the syringe in red, and the tray itself here in green. And so this is just a real-time tracking. And then here we have the table tab, which will look similar to the data tab, but this is for that specific job in the experiment tab. So segment or measurement number, what the temperature of the VROC chip was at that specific run, the viscosity of that specific run, the shear rate tested on that specific run, shear stress measured, the flow rate used, the percent full scale pressure, which is the percentage of the full scale, the percentage of the maximum pressure that the chip can withstand for that given measurement. So 6% all the way up to 75% for this particular experiment. And then here it'll keep track of the measured volume for that run, and then the loaded volume from that particular test syringe, and then what the slope was for the pressure graph, so the R² value of this. So with an R² value of 1, that's really good. That's what we're looking for. And then keeps track of the syringe temperature, the tray temperature, the date, time. So, all right. So that was the experiment tab. So now we're going to click on the protocols tab. So this is where you would begin to make your own protocols and recipes. So here's the recipe tab. You can name your recipe. Here you can give it a description. You can specify what kind of loading protocol this recipe calls for, and then you can select that loading protocol here, then whatever measurement protocol you want, and then whatever cleaning protocol you want, and then you can save the recipe clicking this, and this is where you would type in your name, your recipe name, the description of the recipe. So if you're going to be running the same test across multiple different samples and you don't want to continuously find the same measurement protocol, you can basically have it all saved in one location using the recipe feature. So next we have our loading protocol tab, and so I say do not under any circumstances mess with this tab or this tab. Don't mess with them. If you need new loading protocols and cleaning protocols, talk to our service engineers first, and they will work with you by making their cleaning protocol or a loading protocol for your specific need, and then give it to you after we've tested it here at RioSense. So don't mess with loading, don't mess with cleaning. So the measurement protocol, this is the one that you can alter and use to specify your needs. So again, similar to the recipe, we have the name of the protocol, the description, and then here we have your settings for sample retrieval. So the feature of the initium where once the entire volume of the test syringe has been used, the initium will then retrieve that sample back into the test syringe and then run a test again. So, so some key features here. In order to do sample retrieval, you have to click this box. So use the reservoir or use the air reservoir. So that's telling the initium to pressurize the chip from the air reservoir side of the instrument, which will allow it to retrieve the sample. And then here you can select how much sample retrieval volume you would like for your measurement. And so, and we can go over the best settings for sample retrieval given how much sample volume you have. So naturally, if you loaded 50 microliters of sample into the chip, there's no way you can retrieve 88 microliters from 50 microliters. So you need to make sure that this value is less than the loading value that you are using for your experiments. And so we can go over that later. And then here we can select how tight we want our temperature tolerance to be. So here we have 0.1 degrees Celsius, and then how long the chip must be at that temperature before performing the next step of experiments. And then here you can also select the chip type that you're going to be using for your experiments. And then here you can specify whether you want to build your protocol based on flow rate or shear rate. That's more of a personal preference. Personally, I like to use flow rate because I can visualize that more clearly than shear rate or inverse seconds. And then you have your shear rate sweep type. So here I have stop and go mode selected. And then where you would select your baseline measurements. So I prefer to have each measurement selected here. And then down here on the steps for the measurement protocol. So here, this protocol is an automatic mode setting. So automatic mode is the instrument itself dictating the flow rate and the wait time and the measurement time and pause time for each experiment. So the instrument is doing the work for you here. So if you select 0 for any of these 4 time rates and time scales, the instrument will pick the appropriate time based on the viscosity of the sample. So we recommend, if you have no idea what your sample's viscosity is, and you're running the running on the instrument for the first time, go ahead and run an automatic mode experiment. That way you know what the viscosity is of your sample, and then you can then run it again in the future, having already known what the viscosity is, and then you can build a much more broad experiment. And then here you have temperature, and then the instrument will estimate the amount of time it will take to perform each step, and it'll also estimate the volume. And then here you can select priming. So this is priming the chip. So this step, the instrument will actually throw this data point out, because since it's priming, it will likely not elicit an accurate or representative viscosity value for you. So it'll basically not count that towards your viscosity measurement, because the chip is going from dry to a wetted state, which can cause some massive fluctuations in the viscosity. So just to kind of show you how the estimated volume will change. So let's say I want a 500 microliter per minute flow rate. I want to wait 10 seconds. And as you can see here, it's flagged this. This is estimated volume greater than 80 microliters. So I need to reduce this wait time. So this is the wait time for the instrument getting to steady state before collecting the measurement. And then the measurement time is how long it takes to make the measurement. So here, we have an estimated volume of 125 microliters. That's way too much. So we can reduce this to, let's say, 4 seconds and 2 seconds. And so now we look over here, an estimated volume of 50 microliters. So if you loaded 68 microliters, this is more than enough to prime the chip. So I guess I should have moved that up to here, which we can do. It's pretty flexible. And so, yeah. All right. And so once you've selected and created your measurement protocol, you can save as a new protocol and then name it whatever you'd like, give it a description, and then move on. So next we have the data tab, which will keep track of all your data. And so you can compare data from the same run, different runs, different jobs. So, and it keeps track of all of that. So, so you can, let's say, clear all, and then we want to select the N10 runs. So we have this N10 run, and then hold Shift and click, and it will select both runs of this previous N10 run. You can then select highlighted rows, which will then cause it to select that data that you've clicked, and then now it will populate the graph tab. So this graph tab is similar as the graph tab in the experiment tab, but this is keeping track of real time in the experiment tab. The data tab is showing all features of the experiment. So top left we have viscosity versus time, temperature versus time on the top right, the sensor versus sensor position on the bottom left, and then the viscosity is a function of segment number is the default setting, but we can also look at it from temperature and then zoomed in, temperature and shear rate. So, and these N10 standards are Newtonian, which means their shear rate is, or their viscosity is independent of shear rate. It does not change as the shear rate is increased or altered, so it's a flat line. All right. And so if we look back up here, so run 1, that's the first vial, and then segment 0 is going to show all segments. So if I click this, it will show me all the information from segment 1. So this is actually a good point to show how the instrument works and what wait time and measurement time means. So this run 1, segment 1 is the priming step. So the instrument is pushing the sample into the VROC chip. So the chip is going from a dry state to a wetted state. And so here the wait time is however long the instrument waits before taking measurements. So I can tell from this time versus viscosity graph that the wait time on this particular segment was 60 seconds. I can tell this because after 60 seconds, the line is now bolded, where it's notifying you that these particular points were selected for measurement. You can see it more clearly here, the difference between counted towards measurement here and not counted towards measurement here. So, this is a more dramatic view of how the instrument works. So your wait time is how long the instrument waits before taking or collecting data points and measuring the data points and saving those data points. And so we're waiting for the flow and pressure to reach steady state before taking measurements. So this might be more clear in the non-priming segment. So we'll move on to segment 2, which is the first segment that we used and started collecting data. So here, again, the wait time looks like about 15 seconds, and then the measurement time was about 5 seconds. So 15 plus 5 is 20 seconds. So this segment took about 20 seconds to measure. So again, we waited until the pressure or viscosity measurements reached steady state, and then began collecting data. And this holds true for each segment. So we can look and see for each segment, and then we can get a viscosity value for that measurement here. And then we can also keep track of the chip temperature for this particular measurement. So, and then we can also go and click select 0, which will show all the data for the entire run, or in this case, the entire vial. And then we can also check the next run, which is vial 2 in this case. And again, you can see all the data from run 1 and run 2. And so if you only selected 2 runs, then that's all the instrument will display to you on the data tab. And then we have the table tab here, which is similar to the table tab in the experiment tab, and it's going to show you, again, the run ID number, the sample name, that specific run or vial, the segment, the measurement segment, measurement number, the temperature of the sensor, all the information that you want to keep track of. And so if you want to sort things, you can double click. It'll sort based on like flow rate or shear stress or shear rate, whatever you want to investigate, you can cycle through here. So, and then we can go through the settings tab, which is just showing you here the usage counts for each of the consumables in the instrument, the volume of the solvents being used, and all that good stuff. And then also you can create, user accounts here, and then also look at the service utilities tab. So you can click this tab to reinitialize, or click this button to reinitialize the autosampler. So the autosampler, whenever you start the initium software, will go through like a dummy run just to make sure that it's ready to go. So you can click that, and the noise you're hearing is the autosampler initializing itself. So it's just going through its own diagnostic setup to make sure that it's functioning properly. And then you can calibrate the autosampler, which will cause the initium software to go into the background, and then you can calibrate the autosampler for whichever VROC type, and blah 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 blah. Okay, delete this. All right. Maybe I won't go through that because it takes forever to initialize everything once you go into that wizard. Blah, blah, blah. It's now has to reinitialize everything again because we'll click that autosampler thing. Still delete. Don't save this. Especially this part. This will freak them out. Don't save that part. All right, so we're gonna go back to the settings tab. Try this again. All right, so 3, 2, 1. So here's the service utilities tab. This is where you can keep track of your system calibration and your firmware settings. This is when our service team, service engineers come in. This is the tab that they're primarily going to be working on. What's useful for you, the user, would probably be the diagnostic tab. This will allow you to run a chip test to see how the chip is performing. So here are the reference values for this particular chip, which were collected on the March 18th of 2020. And then looks like it's in spec, in range, which makes sense. The reference date is not that long ago. And then you can select which kind of tests you want to run. So this, when you click run on the instrument, it's going to go through and run these 5 tests for you to make sure that the instrument is running properly. But if for whatever reason, when you click run and the instrument fails, if you come over to the service utilities tab under the settings parent tab and then click diagnostic testing, you can go through and specify exactly which tests to run. So these 3 tabs you will probably use. So you can run these tests later. Next, we have the recipe import and export. So if you have a recipe that you want to load or export to a different instrument, that's all controlled here. So, and then you have your system settings here. I wouldn't really mess with this tab either. And finally, the information tab. So here we'll tell you the software information at the top. So the software version, and then here it'll tell you the chip information. So the chip serial number, the use count of this chip. This chip has only been used 494 times. The width of the channel, the exact depth of the channel, its minimum pressure, its maximum pressure that it can withstand, its minimum and maximum shear stresses, its minimum and maximum temperature, the positions of the pressure sensors along the chip. So this information is really useful when you're building shear rate sweeps. So you want to go from low to high, essentially, when you're running shear rate sweeps. And then this tab here will tell you the product info of this initium. So without further ado, we will move on to collecting and running an experiment. Okay, so now that I've walked you through, gave you an overview of all the different components of the initium software, we can now go and set up an experimental run. So right now I have 2 samples, a protein in PBS, phosphate buffered saline, and a protein also in PBS but with an additive. So 2 samples, and we want to compare their viscosities. So here I have the previous run already saved from the initium. So this is the N10 oil run. So since I have 2 samples, I want to remove one of these vials. So I'll delete this selected row. And so now vial 1 and vial 2 remain. So for vial 1, I'm going to name it PBS. And then for vial 2, I'll write PBS plus additive. And then I'm going to select the loading protocol. And so now, since this is a protein, we want to use our buffer cleaning loading protocol. So here we have our standard buffer cleaning protocol. So I'm going to select that here. And then I want to also select that here. So standard buffer cleaning. As for the measurement, I have no idea what the viscosity is of either of these, so I'm going to select an automatic mode run. So just need to find one. There's a lot of measurement protocols. So we have our automatic mode here. So and if you move on, you can actually get some description information. So this one retrieves at 46 microliters. So we will again look for automatic mode. And then for cleaning, we want again to match the type of cleaning, so buffer cleaning. So we want this cleaning to match that as well. So we want to have both buffer cleaning selected and the chip type selected. So we want buffer cleaning and B05 since we're running on a B05 chip. So we will do the same here. Excellent. So this is setting up an automatic run. So the type of vial that we use needs pre-pressurization on, so pre-pressure on, and then we want to run this close to room temperature. So right now the tray is currently at 24 degrees Celsius, while the chip and syringe are at 23.5, so I'll set the tray point to 24 degrees, keep it consistent. And then everything looks good, so we'll go ahead and click run. And so now when we click run, it wants us to name the instrument, or name the job, and so we'll name this initium demonstration. And then if we just double click, it will automatically populate the job name into the description. And then I think this is good enough. You can just maybe put the chip information, so B05251. So we have the temperature control on, and then we can select OK. So here, this is the pre-job run intelligent diagnostics. So when you first click run, it will say, okay, the pre-run checks and diagnostics will be run to ensure the health of the instrument before it runs the job. And then if there are any issues, it will notify us. So it looks like the cleaning solvent volume is okay and the hardware use counts are okay. So we can go and look at starting to run. So click run, and then so now it is going to test the chip, and then now it's going to do the solvent bottle leak test, and then if it finds any issues, it will alert us, and then we can go through and solve the problem and get moving on to our experiments. Right, and with that, thank you for your interest in the VROC initium. Do.